Good evening, everyone. This is Anand here, joining you again. Um, I'd like to take you through a journey of data science, AI, machine learning, and um, how these three domains are very closely related to the domain of big data. Right. Um, as you all know, we are in an era of data explosion. Right. Um, what we will be covering is why why there is data explosion, how big data came in uh, as a practice or a domain to handle this data explosion. Um, what can bad data do to an organization? Where does data science, AI, and ML fit into the story? And more importantly, we will also see how what are the various applications of AI and big data put together in today's enterprise world. Um, in the process, we will also be talking about AI and its evolution, the difference, what differentiates AI, machine learning, and deep learning, and some of the objectives of AI as well. So, net, what we'll be taking away from this 1 hour webinar is going to be the power of data, where does big data fit into the story, and how AI and ML has nicely started playing a role in terms of using the big data. So let us start with the current day scenario, right? And why do I call it as era of data explosion? Today, as we speak, we are already at a stage where we are around easily around 80 to 100 zettabytes of data. Like, what do I mean by 80 to 100 zettabytes of data, and what caused this explosion? We all know that we are in an era of social media, social network, mobile, internet data. There are so many channels of data, that has enabled uh, uh, the explosion of data, right? You Every single mobile every single message that you do in your WhatsApp, every single transaction that you do online, every single what do you call video call that you do through your device, all of that adds huge volumes of data, right? So in one of the researchers in 2018, as you could see, um, as of 2018, there were 33 zettabytes of data, and the expectation is it's probably going to go 5 times or 6 times by 2025. And I do believe this number is actually low, given the way that we are given the way that we are exponentially producing data, right? So, by the way, what is zettabytes? Zettabytes is 1 followed by 12 zeros. So you can imagine the volume of data that we are all generating on a day-to-day basis. Um, with all of this, what research organizations had already forecasted is, if you have so much of data, you need some mechanism to store, process, and engineer around this data, right? And that's exactly where the market for big data was burgeoning, right? Was blooming all along. So by 2022, we are talking about 190 billion dollars spent on big data alone. So that begs to ask a question: what is big data, right? And let's try to understand big data in its simplistic terms first, and then we will quickly look at some of the examples of big data, and then what what comprises big data, right? So if I have to give some definition for big data, and there are various different definitions from the simplest to the most complex, and this is somewhere in the middle. If I have to give a definition, the definition for big data is it's a domain that enables storage, processing, access of extremely large data sets, right? And for what purpose, right? The purpose is to basically help analyze these large data sets. So what do I mean by extremely large data sets, right? If I have to simplistically say, your home desktop that you have, when, let's say, you have a desktop of 500 gigabytes, right? And the moment you have an application which takes over all the 500 gigabytes of hardware, and then probably your 8 GB of RAM, you already are facing a big data problem, right? um, I'm not talking about these simple examples of big data. I'm actually talking about enterprise level examples, right? In an enterprise, there are going to be huge volumes of data that is generated day in and day out because of various different diversifications of business. the e-commerce business, the online platforms, and operational applications being generating data day in and day out. All of this put together um, exponentially increases the rate of data explosion. So some of the applications of big data, obviously it's your social media platforms, right? Facebook, Twitter, Instagram, YouTube. So if you look at Facebook, 500 terabytes of new data gets ingested into databases every day. We are talking about 500 terabytes of data getting created in Facebook databases every day. That's not normal, right? And if you look at some other example, a jet engine, when for a 30-minute flight time, there is a 10 terabytes of data. These are all excellent examples of the volumes of data that we are speaking about. If you look at YouTube alone, 400 hours of video is uploaded in YouTube every minute, right, worldwide. And these are going to be huge applications which will have which which are very, very clear use cases of big data itself. But if we have to understand big data at a little deeper level, many of you would have probably seen these 5 V's of big data, right? And apparently these days there is a sixth V that's also coming up. So the 5 V's of big data are around volume, velocity, variety, value, veracity, right? And the sixth V is basically variability. And I'll quickly explain what each of these and why these define the term called big data. By the way, big data is not a technology, it's a domain, it's also a concept. There are umpteen number of tools that help with big data, right? So do not think of this as just technology, or do not just think of this as Hadoop and big data are one and the same, right? Big data is a domain, Hadoop is a tool that helps with big data, right? So that's one of the first tools or pioneering tools that help in enabling big data. So now let's come back to volume, velocity, variety, value, and veracity. So what do I mean by volume? I'm talking about huge volumes of data. The examples of Facebook and YouTube and the jet engine example, jet flight time example, they're all very clear-cut cases of huge volumes of data. So how do you handle huge volumes of data, right? So that is the first thing, first task that a big data platform, takes care of. Now, your data, when we're talking about huge volumes of data, these volumes of data can be of two types, right? These volumes of data can be called as data in motion and data at rest. What do I mean by that is there are some aspects of data that keep on coming in, coming thick and fast. What do I mean is they are called as streaming data, right? Your YouTube data, your Facebook data, your video data. These are all data which is streaming data, and they come at great velocity. They keep hitting you at different frequencies, right? And the streaming aspect, because of the streaming aspect of it, the data keeps on getting updated, right? So there is huge speed with which the data changes. So, and that's why velocity becomes important. A good big data platform has to handle both volume and velocity with equal balance, right? And the third is basically the variety of data. So when I say variety of data, until the term big data was coined, right, we only had structured databases and data warehouses, right? We used to have the terms called blobs, right? But they were all used in enterprises with limited with limited use cases, right? For example, big data can handle structured data, which is your tabular data, your data in structured databases, SQL, and whatnot. It can also handle unstructured data that is in the form of text, which can be handled by NoSQL databases or document databases, we say, like MongoDB or Cassandra. But at the same time, when it comes to unstructured data, we are also talking about video data, audio data, image or pictures. All of this form a variety of data. No more are we just talking about table data or data that is there in Excel sheets or sequential files, right? We're talking about different varieties of data, and that's where variety becomes important. And while volume, velocity, and variety are very, very important, and that's one of the reasons why many organizations started turning towards big data, right? Value has started playing a very important role in the last many years, right? I would say half a decade, I would say at least. Why? Because organizations, when the term of big data got coined, many organizations were so excited that okay, they wanted to get into big data. So what they did was they very quickly created Hadoop practices or big data practice, and they started building big data platforms automatically, right? But the challenge is, once the platform was built and once the data was brought into the big data platform, what happened was um, organizations started questioning, now what do I do with this data? How do I use this data? And that's when they realized that they should have started asking this question before even building the big data platform, right? So if you take the Googles or the Facebook or the Twitters or the Instagrams, they all started with the end in mind. They all knew very clearly what is their user base, who are they going to cater to, and what kind of services are they going to give to the users. And because of the fact that their requirements were, they created their requirements very clearly, for those requirements they were able to use their big data platforms very well. So value became a very important aspect for organizations. So by value, what do I mean is how to commercialize the data, how to make how to make the data work for you so that you get revenues, and that's where the value becomes important. Now, last but the most important aspect that the organization started seeing is veracity. Veracity is truthfulness, right? What do I mean by truthfulness? How true is your data? Right? Have you validated the data? Have you verified the data? Validation and verification are two different techniques, right? Validation would just say whether a data needs to be, a numeric or non-numeric. It can say whether the data looks like an address, whether the data looks like an employee ID. But verification is basically going and verifying whether the employee ID is really present or not, whether the address that the customer has given is a real address or not, right? So truthfulness of data also has become a very important aspect of big data as well, right? So when we talk about these five, what has also happened is a sixth V, or the sixth angle of big data has also started springing up, which is called as variability. So what do I mean by variability is, organizations have started to understand that the data that they are ingesting, like let's say Facebook is ingesting about 500 terabytes of data every day is what we learned, right? But is it going to be 500 terabytes every day? Maybe or may not be, right? On an average, it's 500 terabytes. But what today there could be 500 terabytes. Tomorrow there could probably be just 100 terabytes. So what happens is, a big data platform should be cognizant of the variability of data. Meaning, while your platform should handle 500 terabytes worth of data, right? It should be able to handle variations, like whether it is 500 or 100 or 50 with ease, right? And that's where variability comes in play. Okay. So when we talk about big data, there are several tools that come into mind. One of the top most highly used tool is Hadoop, right? Hadoop is a very powerful big data platform, right, which allowed the foremost big data platforms to be built, and it's also open source, so there is no specific licensing cost around Hadoop. But Hadoop was one of the first big data platforms that helped in commoditizing big data, right? As of now, understand Hadoop as um, the Java of big data, right? Because that's the first tool, or the first and foremost tool that made people understand that big data can be handled, right? So that's the aspect of that's a very quick explanation of what Hadoop is itself. So when we talk about big data, we were talking about just ingestion of data, right? Or just data getting created. But we also have to understand, what do we do with existing data? That there is more, as much as data gets created, there is also a big issue of data being corrupted on a day in and day out basis. Why data is being corrupted? Because when we talk about huge volumes of data, there is every possibility that the same data gets updated due to various channels. Like for example, if you take your bank account, right? You operate your bank account at least, let's say, once in your week or once in a day, right? However it is. So every time that you do a transaction, there is every possibility that that data can get corrupted if some of the processes around the data are not handled properly, right? So what happens is, the other challenge with data is data being dirty, right? Dirty data or bad data. So what do I mean by, what is the effect of dirty data or bad data is, 30% of every organization's revenue is spent on dirty data, right? And an average cost that is spent by any organization to clean up, to maintain the sanctity of data is somewhere around 9 to 15 million dollars yearly, right? So when organizations are looking at enriching their data, their primary role is also to make sure that that data does not get spoiled. So what do I mean by data does not get spoiled? We are talking about what are the three aspects that cause bad data, right? Three aspects that typically fail and resulting in bad data. The number one is correctness of data, right? When your data is not correct, it causes bad data. Number two is completeness. When your data is not complete, it is a cause of bad data. And number three is consistency. When your data is not consistent. So what do I mean by correctness of data? So that's when I mentioned the veracity of data, right? So if I take address as a as an entity in your bank account, in your banking profile, in your account profile, the bank system should be able to understand that this is your address and your address is always updated and it is always maintained correctly, right? If one of your bank if one of the systems have the right address and the other system does not have the right address, there is every possibility that the address can get corrupted across the board, right? So so bank systems have to be designed in such a way that the data correctness is maintained at all point of time, right? Completeness of data is, let's say you have your social security number or Aadhaar card number, and instead of having the full number, you probably only have partial data, right? So that means your data is incomplete and your systems are not efficient enough. The systems in your organization are not efficient enough to track that the data has been incomplete. And as a result, that causes bad data. When your Aadhaar card number is partial, what will you do? Your identification of the client themselves becomes impossible. So what happens? Someone has to go rectify that information for your record, right? And then that causes rework and that costs money, right? So all of that becomes a challenge. The third is consistency of data. What do I mean by consistency of data is, let's say you have two or three bank accounts. Your data in account one is correct, right? Your name, a social security number or Aadhaar card number, your address in one account is correct, but the data in another account is not correct. Somewhere your name is missing a letter, your address is probably missing the street name. It is not because you did not give that. It could be because of the fact that the bank systems did not sync up properly, right? And that could result in consistency issues. All three issues put together can create huge pain for any enterprise in the form of bad data. Okay, so now if you look at it in terms of money, you know, if you correct bad data, the cost of cleaning bad records, it is, and what is the cost of bad records, and the total savings that a company can do by managing bad data, or by cleaning up and making sure that there is proper data governance, is somewhere around what do you call, $8 million, right? So that's big money yearly, right? We are talking about huge amount of money saved if you maintain the data properly. So how is this related to big data? So when we are talking about big data, please do not think of that as just analysis of data, right? I told you monetization of data. In this monetization, the biggest monetization that you can get is by saving your data from getting corrupted, right? And that is where big data systems are also playing a big role these days. Now the topic of today's session, that would be a good segue to for the topic of today's session, right? How is big data and AI coming together, right? See, think of this as big data is just a platform to create, ingest, store, and process data. It can enable analytics, but it is not an analytical platform itself, right? Think of big data as a large database or a platform that stores and engineers data. That's it. It cannot give you insights. It cannot, the platform by itself cannot give you ideas. It cannot by itself give you predictions. So to monetize the big data, going back to the value aspect, to monetize the big data, a platform, a domain is needed, and that domain is AI, right? And that domain is AI. Now, if you look at how AI is now nicely plugged with big data, is they have almost become a perfect couple, because almost all AI processes need a large volume of data for your AI algorithms to learn and excel, right? So your AI algorithms become better when it is allowed to learn from bigger volumes of data, right? I'm going to use this term with a pinch of salt. It is not always the case where should I always have 100 years of data for my AI to work well. No, that's not what I mean. What I mean is, when you have larger volumes of data, there is a higher probability that your machine can learn better, right? From that perspective, big data is a very nicely perfectly poised solution or data solution for many AI products, for many AI solutions as well. So what AI does is AI consumes the data persisted in big data environments, and what big data does is big data allows AI to use its data for the monetization purposes, right? So the outcomes of this is going to be, you now have the capability to use AI to analyze large volumes of data. Large volume analytics at scale becomes possible. Because of the fact that AI can work on large volumes of data, decisions become better, right? And why are decisions rapid? Because big data platforms are built for rapid data processing. As a result, like platforms like Hadoop allow for rapid data processing, and as a result, when AI systems work with Hadoop platforms, there is an opportunity for rapid decisions, right? And data driven automation, what do I mean by data driven automation? Is certain decisions can be taken automatically. You do not need manual intervention for decisioning, because AI is working on the data and using the big data platform, and as a result, decisions become faster as well. So when we talk about big data, right, there is there is no count of modules, right? I mean, if there was a question around how many modules should we need to know about big data, right? Think of big data as a you think of big data as a domain, as a concept. Understand big data first conceptually. Then I would say start with learning platforms like Hadoop, right? You learn one big data platform properly, which is Hadoop. That is more than enough, so that you can start your career as a big data engineer with Hadoop alone. And Hadoop is a very powerful big data tool, no doubts about it. So let's move on now to understand more about how AI and big data work. It is also important to understand how organizations today are approaching data, right? What is the data landscape in the organizations? Where does AI and data science fit in, right? So there would be questions around what is data science, what is AI, what is machine learning. So the the way I would like to answer that question is, data science is the umbrella domain, right? Is the superset of AI, machine learning, business intelligence, and whatnot. Why? Because wherever there is data, there is going to be data science. So, how are organizations maturing when it comes to data science? Organizations start with basic reporting, your Excel sheets, your tabular data, your data in databases, and whatnot. And then some organizations get to the level of building data warehouses. So, what is a data warehouse? When individual databases are combined together, aggregated to help business aggregation, or to help with some business use cases, that's where data warehouse come in play, right? Like, for example, if your CEO wants to know the cash flow of the company, right? So when we talk about cash flow of the company, you're going to talk about what are the products that are sold, what is the sales revenue, what is the seat cost of an employee, how much does an employee cost. So you're going to have HR data, you're going to have sales data, you're going to have product data, you're going to have applications and software data, you're going to have purchases, you're going to have raw materials. All of this data will be in individual databases, right? And when these individual databases, the data gets aggregated in a data warehouse, a data warehouse allows for better business intelligence, right? And that's where business intelligence platforms come in play. Now, the challenge with business intelligence platforms are that they are not very statistically oriented. Business intelligence platforms are good, but they only allow you to they expect you to have a large amount of domain knowledge, vast amounts of domain knowledge, and as a result, not everyone can call themselves as a true BI architect. They can call themselves as a BI technologist, but not a BI architect. Why? Because BI has to go hand in hand with the domain knowledge, right? Whatever domain it is. When I say domain, I'm talking about retail or business or manufacturing, right? And that's when the domain of analytics came itself. So what does analytics mean, right? If I have to put it in just one single term, analytics is a combination of your domain, your technology, and statistics, right? Analytics is a combination of, I repeat, domain, technology, and statistics, and that's what BI was missing. That's what business intelligence was missing. So when we talk about analytics, analytics is of four different types, right? We're talking about descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So descriptive analytics is when when a problem comes to you, most of the times we react to the problem. Most of the times we react to the problem, we almost confirm or assume that the problem is correct, whatever is given to us is correct, and we don't cross verify or check whether the problem really happened or not, right? Descriptive analytics is a technique in the world of analytics that first enables you and actually pushes you to verify whether the problem that is given to you is actually a problem or not. So that's why it deals with what happened. And how does it do? By the help of analytics, by the help of statistics, and some domain knowledge. I'm not saying domain knowledge is not important. Domain knowledge is very important. But data can allow you, I mean, when you learn the data through statistics, what happens is it allows you to learn the domain better. It allows you to learn the domain faster, right? So expedited learning of domain becomes possible when you combine the power of statistics and technology, right? And that's where descriptive analytics comes in play. It first allows you to verify and validate whether the requirement that you have, whatever problem that you are solving that is given to you, is actually a problem or not. And then comes diagnostic analytics. Diagnostic analytics is whichever problem that you are solving, what is the root cause of the problem? Let's say if sales revenue has gone down, um, you you have to first understand whether the sales revenue has gone down, and then you will have to confirm, or you will have to say why it has gone down, what caused it, right? It's called as causal analysis. In our normal day-to-day work terms, it's called as causal analysis. So diagnostic analytics is again something that uses statistics and technology and domain to really understand why the problem happened. Now, with the help of descriptive and diagnostic analytics, the next step is prediction. What is prediction is when you know that in the case of sales forecasting or sales revenue, when you know that your sales revenue is down, if you are an enterprise and you know that your sales revenue is down, you have verified with the descriptive analytics that sales revenue has been consistently down. And then you have also validated with diagnostic analytics that what is the problem for sales revenue. And the problem for sales revenue could be, you are hit by this coronavirus pandemic, right? It could be a problem. Now, once you verify it and once you validate and understand the root cause, rather than going and jumping into correction and preventive action immediately, if there is an opportunity for you to predict what will happen in the future, if there is an opportunity for you to predict, okay, how is your sales revenue going to be 6 months down the line, right? If this continues, then you get a better idea about how to strategize, right? And that becomes your predictive analytics. Predictive analytics is what is the future, right? What will happen in the future. And for prediction, you would use statistics, you would use your descriptive analytics, you would use your diagnostic analytics, you would use your domain. And that's predictive analytics is where AI starts coming in play, right? And it is during predictive analytics you start applying AI techniques, right? And that's why if you see here, predictive and prescriptive analytics is when you start applying various different AI techniques, right from machine learning to deep learning to some recommendation systems and reinforcement learning and computer vision. These are different domains within the AI space itself, right? And last but not the least is prescriptive analytics. Why prescription? After understanding the problem, after understanding what caused the problem, and after understanding what will happen, what is the natural next step? The natural next step is, go and give suggestions, go and give recommendations, and that's where prescriptive analytics comes in play. Okay, so so now when we understand what is data science, and as I said, data science is what? Data science is the all encompassing domain of all of this that you see here, right? Your basic reporting, your business intelligence, your descriptive, diagnostic, predictive, and prescriptive, and all AI put together is data science itself. Okay, so then why? So what if we start looking at data science as a domain, um, and sum it up in three areas? Data science, if you could see, if you could arrive at a logical conclusion that data science comprises of your technology, your your math and statistics, and the domain knowledge, all put together becomes data science itself, right? um, so now how do you become a data scientist? What are the qualities that a data scientist should have, right? Before we delve deeper into the AI space, which is a subset of data science in my view, um, how do we categorize what is data science, right? And I just want to take a very simple example of a few months back, when I traveled from the airport in my city to my home. I was just talking to this cab driver, and he drove me. It was late at night, midnight actually, 12 a.m. or 1 a.m. And every time I land in my city around that time, I almost always see this guy, right? 4 or 5 times I've become his customer. So I asked him, like, how is it that I see you during this time? And I asked him, how does he operate, right? And if you and the answers that he gave were amazing. He said he operates only between 12 and 4 or 5 a.m. in the morning, and then he makes about quite a lot of trips in these 5 hours. And to maximize his profits, right? And I asked him, why does he follow that methodology? And he said that is the best way that he can maximize his profits. And I asked him what are the parameters that he looks at, and he said time of driving, which is 12 and 5 in the morning, right? And start and end location. He doesn't drive beyond 3 or 4 kilometers around that location, around the airport. The distance covered, maximize the number of trips because of the distance covered. And he almost always knows the customers, because most of the times he gives me his number, and then I directly call him, and then we book a trip, right? So that's how it works. So if you see, for a driver who has no clue about what data science is, to to maximize his profits, he follows various different methodologies, various different parameters, to improve his day-to-day your work, as well as day-to-day profits, right? What what is the goal here? The goal here is to maximize the profit, and this is going to be his goal. If he has to form a data set, or if he has to form a data science project out of it, he will be predicting what will his profit be in the future if he continues to use these parameters, right? In data science terms, this profit becomes the target variable, the variable that you are going to predict. And in when I say data science terms, I'm talking about machine learning and AI. And these variables are going to be the independent variables, the variables which will help him predict the profit, right? So the descriptive analytics that he would have done in his mind is, what should be the time of driving, what should be the start and end location, what should be the distance covered, the number of trips, which customer should I go. All of this will be the descriptive analytics. The diagnostic analytics could be, if if he goes through all of this, what will be the cost? Will my profit go up? Will my profit go down? Will my operational cost go up or down? That would be the diagnostic analytics. That he can achieve day on day or month on month, right? So that will be a perfect example of data science itself. So now is a time when we start understanding, where does this all fit in? Like, we saw data science, and we realized that data science is a superset of AI and ML and deep learning and whatnot. But it is also important to understand that more than data science, the terms AI and ML and deep learning have started playing a big role in today's world, right? So it's important that we find how these are related. So if you look at AI itself, if I have to draw another circle, data science is the biggest circle, right? And then comes your artificial intelligence. And with artificial intelligence, within artificial intelligence, you have machine learning. And machine learning is again split into supervised, unsupervised, and reinforcement learning, right? And within the machine learning space, when I say within, if I have to do a deep dive of understanding data, then I use deep learning, right? And for ordinary data, when I say ordinary data, numbers, I probably use artificial neural network. For me to uh, predict a numeric data, or for me to predict a class data, I use ANN. for me to for me to really do image data, for me to really work with image data, I use CNN, convolutional neural network. For for me to really understand human language, textual data, right, I would have to use language processing or natural language processing, right? So the AI realm is basically made of your machine learning and deep learning. Now it begs to ask a question: what is AI, right? And where does AI fit in, right? So let us take a very simple example of email processing in your organization. So your organization would have an email server, right? There will be some team that would be appointed to monitor that email server, primarily to classify between spam emails and good emails, right? Ideally, if AI were not there, if AI was not there, someone has to write a software program, and the software program has to really go through a set of rules. Like, okay, if a mail has certain unparliamentary words, then classify the mail as spam. If the mail has some websites that are blacklisted, then classify that mail as spam. If the mail comes with just a subject hi, classify the mail as spam. These are all rules, and your software program has to understand these rules and appropriately process your emails, and then classify them as good emails or spam emails, right? But the challenge with this approach is, every day huge volumes of emails are coming, and every day different varieties of emails are coming, and there is and every day you cannot be updating your software to to classify the emails correctly always. It's going to be very, very difficult, right? Because it's almost impossible to keep writing a software program all through the day. It doesn't make sense, right? And that's exactly where your AI algorithms come in. if if the same business use case is if you apply machine learning on this use case, what the machine would do is it will keep on learning from your emails. Just like how a human brain learns from the emails, the machine will keep on learning, right? It may not classify everything perfectly in the beginning, but as the learning improves, it would be able to classify an email as spam or not spam over a period of time properly, right? So what does this avoid? This avoids your software program to be updated time in and time out, number one. This avoids uh, the data gets enriched, because your machine learning algorithm will keep on learning, because your algorithms are built on mathematical models, so it will keep on learning. And the third is, you almost have a completely automated process of spam and ham. Best examples are your Gmails, right? In Gmail you have spam folder. I'm pretty sure Google uses machine learning to classify the email as that particular email as spam. It is a combination of both business rules and machine learning logic out here. So before we go to the evolution of AI, there are a couple of there is one question that I'd like to answer. What is the difference between data lake, data warehouse, and big data? Okay, so data lake is essentially another name for a big data platform. Okay, data lake and big data are not different, they are the same. Okay, so when I am solving a big data problem, when the data that is stored in the big data domain, right, is stored in the form of a data lake, it's just a representation, right? What is a data warehouse then? A data warehouse is more around is a data repository that stores more structured data, right? That is how data warehouses were initially built for. But a big data platform or a data lake stores unstructured data also, like images, pictures and whatnot. For example, if some of you had worked on AWS, right? Amazon AWS is a cloud platform, and it offers what is called as S3, right? S3 services, I would call it as a data lake. Why? Because it it you can put any file inside S3, right? I can put an Excel file, I can put a picture, I can put an audio, video, whatnot. So AWS S3 is a very solid example of what I call as a data lake. And it's also closer to a big data platform as well, right? So, but a data warehouse typically is used for storing structured data, right? So that is the that would tell the difference between a data lake and a data warehouse. Now, let's go back to our AI, AI topic. So who coined the word AI? It was John McCarthy. It was coined as early as 1956. Whether you believe it or not, AI is a very old concept, but newly implemented or repurposed, right? So I mean, we are just learning AI now, but there are veterans like John that have been having AI as their bread and butter, right? Now, when we talk about AI, there are basically four broad objectives of AI, right? The first objective is systems. AI is a system that thinks rationally, meaning it focuses on a reason and and a general concept of intelligence, right? When I say focuses on a reason, when you give a problem, it should be able to think logically with a reason. And the second objective of AI, it should act rationally. While thinking is to understand the problem, acting is to take decisions, right? So apply the decisions or apply the understanding, right? So that's where that would be the second objective of AI. And the third objective of AI is think like humans, which I believe there are AIs that have not yet come there. Well, other than the gaming industry, in the real time industry, there are very few cases which are not fully there. And the fourth objective is start acting like humans. So if you see, it is think and act, right? In both the cases, think rationally, act rationally, think like humans, act like humans, right? So and with these four objectives, there are three broad definitions of AI. One is artificial narrow intelligence, two is artificial general intelligence, and three is artificial super intelligence. So what is artificial narrow intelligence, right? um, Artificial narrow intelligence is they operate based on rules and a set of machine learning algorithms which help them to take decisions. So if you look at the Apple Siri, or Alexa, or Amazon Alexa, or Google's Google Assistant, they all use NLP algorithms. They have some training data on which they are trained, and they perform certain actions based on what they have learned, right? So this is narrow intelligence. Based on, you look at the past data, and based on the past data, you identify the patterns, and based on the pattern you perform some actions, right? So the AI performs some actions. The next example would probably be the robots that manufacturing companies typically use, right? They are very clearly instructed robots, right? And they would perform certain operations automatically based on rules and constraints. The third example would be the email spam filters that you are using. And in our mobile phones, we have AI face recognition AIs, right? Or we have an AI selfie camera. That's what mobile phone companies advertise today, right? All of this belong to artificial narrow intelligence. Then what is artificial general intelligence, right? There are very, very few examples of artificial general intelligence, but I am seeing that the industries are really focusing on this. For example, Amazon Go is a platform that can be called as artificial general intelligence. What Amazon Go does is primarily it's a shopping experience where a customer can get into an Amazon shop, right? Start start picking up products and putting it in their baskets. As they pick up products and putting it in their basket, a virtual basket gets created, right? A software basket gets created, and every product that the customer is picked up is recorded by the camera, and the price of the product gets added to the basket. Okay. And as the customer completes the shopping experience and he or she walks out, they don't have to do the payment at all. What happens is when they walk out of the Amazon shop, from the virtual basket, the price of the product gets deducted and it is charged to the customer's card or Amazon Pay account or whatnot, right? So that is where artificial general intelligence happens. Why is it general intelligence? Because um, the AI is able to monitor the products that the customer has picked, automatically take some actions, add more information to it, and finally remit the customer's account accordingly, right? And that's where artificial general intelligence becomes a very, very interesting scenario. And what is artificial super intelligence, right? We are almost talking about creating a human being. right? And that's something that many companies are trying to, right? Areas like reinforcement learning, they are applied a lot, but I think we are still a long way to go when it comes to artificial superintelligence. Now, what are the type of AI agents that we are talking about? One is basically your conversational AI, software bots, and ML algorithms, machine learning algorithms that are there. And then the physical agents, your bots, right? Self-driving cars, delivery robots. These are the type of AI agents. So it begs to ask a question: how does AI work, right? In a typical software environment, or you can also understand what would be the job of a data scientist or a AI algorithm model developer on a day-to-day basis. So what you have to do for any problem. So let us take that you want to predict the sales revenue for the next year, right? So you first, the AI process inputs the data. What is the data? The past sales data it inputs, right? And then it performs descriptive and diagnostic analytics out here. The input data goes into the machine learning algorithm. The machine learning algorithm learns from the data, right? And there is a training effort that happens. When I say training, you think of this as a process of the algorithm learning from the data, and then there is some prediction that happens. That prediction is fed back, right, into the algorithm and says whether it is a good or a bad prediction, right, accordingly. And when this model gets perfected, when it goes happens again and again and again, you get a better model. Iteratively you get a better model, and that model gets moved on to production. And this is typically how a AI process works. So, but if you look at it deeply, what really happens, the machine learning itself is split into supervised and unsupervised learning. So when it comes to supervised learning, we are talking about two types. One is regression, another is classification. So when I say regression, I am actually predicting a numeric data item. For example, if I have to predict what will be the next year's sales revenue in dollars, that is a regression algorithm. But if I have to predict, will the sales revenue increase or decrease? That becomes a classification algorithm, right? Similarly, unsupervised learning is my data, the file just has the data, but it doesn't have any column names. It doesn't have any reference to the business. How do I analyze this data, right? So unsupervised algorithms helps in grouping the data that through a mathematical logic, through a mathematical model. And then that grouping is called as clustering. And clustering is one of the famous unsupervised learning algorithms as well, right? So while we looked at what is big data, how big data, what is AI, how big data and AI are combined together, what is AI, and we also looked at what is how is AI working on a day-to-day basis, and what is machine learning. It is important for us to understand the applications of AI in various different industries, right? I've had about 2 slides to look at it, but these are not just the applications. There are many more to it, right? If you take the banking industry, right, right from fraud detection to customer onboarding. How do I onboard a customer automatically with the help of AI, right? When I say onboarding a customer, account opening, right? And what is how does how do you process that know your customer, know your customer activity, right? How do you verify a customer signature, right? And how do you segment the customers? Who are your good customers? Who are your loyal customers? Is this customer going to churn out or not? So banking and financial industry is now really starting to understand AI, in a working on AI in a much more deeper fashion. Now the next one is basically your transport and delivery industry, right? If you look at transport, I'm talking about the Ubers, the Olas, right? Cab companies, Grab and whatnot. They all use AI for optimizing the transport routes, identifying peak and non-peak times. Many a times you would be surprised that the pricing in peak and non-peak times change automatically. How is it happening? It is not just rules, it's also an AI that's running internally, right? Tracking a vehicle, this becomes a very important aspect these days. In the delivery industry, we are already talking about many of these Flipkarts and Amazons. They are all looking at solutions around how the package that they deliver is not damaged, right? There are AI solutions that are being developed around it. How the delivery can be done quickly. Platforms like Swiggy, they even predict delivery times, right? All of this becomes a very important set of AI use cases. Language understanding is a very interesting domain, and it can become a career for many people, right? um, uh, Language translation, natural language processing is a domain which helps in understanding the human language, translating the human language into machine language, and then apply rules and then apply analytics around it, right? That is one. But at the same time, we are talking about voice to text, we are talking about language translation. Google Translate is a fantastic tool for that matter, right? Understanding customer sentiments, right? Customer sentiments are typically verbatim in nature. How does an AI process help understanding it, right? So these are all very strong use cases when it comes to language understanding. Education industry is now undergoing a change, and I think in coronavirus times there are many products that I'm seeing that are really trying to push AI into their product portfolio. For example, how can we allow children to take exams from home, right? How can certification exams be done from home, and how an AI can help in looking or monitoring the student behavior during the exam, and then be able to appropriately take actions or give alerts, right? So that is something that's interestingly happening in today's world. Education industry is a big time AI industry. A lot of AI opportunities around it. Manufacturing is definitely an area which is close to my heart, where AI is something that's slowly seeping into. But I do believe that after what we are facing with the current coronavirus pandemic, I do believe manufacturing industries will start using AI more and more, right from inventory control and inventory management, purchase of raw material approvals, and predicting mission wear and tear, sale order prediction, and using that for revenue prediction. Manufacturing industry, the AI opportunities are high. And the best thing about manufacturing industry is companies that use ERP tools have huge volumes of data. So running AI use cases on this may not be a problem at all. It might take some time for the algorithms to get better, but building use cases on this may not be a problem at all. What about the other industries like wind, medicine, image processing, BPO services? I mean, all of these industries are hugely impacted as well. And I'm saying this because with what we are seeing today, in the next 5 to 10 years, I do believe AI will play a huge role. And the way it will play is, you are also talking about automated AI platforms coming in, right? Auto MLs are coming in. So it's only right for us to really focus on AI as a platform, as a career, right now itself, right? So uh, I mean, to end our webinar, I just wanted to show you an AI ecosystem, right? When I say AI ecosystem, it is already so many tools that are available, right? What does this tell you? This does not tell you that you have to understand every tool. No, that's not what it is. This only tells you the potential of what this domain offers, right? You can just pick up a few tools and become a master in it, right? And that's good enough. You don't need to learn every single tool here. But remember that the market is so opportunistic in nature, that there is so many companies that are competing, and so many new tools are coming in, right? So that is something that I want to be apprising you of. Now, if you also see, I'm not just talking about the AI platform here. I'm also talking about the data platform, because AI and data, they are inseparable, right? And it's going to be very important for us to understand that if we want to get into the world of AI, we first understand the world of data better, right? And for understanding the data, we need to be able to really apply statistics in all our descriptive and diagnostic analytics process, right? So with this tool ecosystem is so awesome that you don't really have to worry, is AI the career for me? No. On the contrary, you should say, what are the opportunities that I look at? So a common question that people ask me is, should I leave my current job, right, and move into AI, right? My request for you all is, if you are already at a state where you've spent many years in your current job, you know the domain very well. Your first and immediate role that you have to play is, in your current domain, how you can implement AI. right? Start with that. That will be the first question. Do not try to move away from your domain, because you are a veteran in your domain. And once you understand AI, you are the right person to implement use cases, AI use cases in your domain. So always start with that, and that will be a great way for you to start your AI career as well, right? So some trends for you before we wind up is, and these trends are from Stack Overflow. As you could see, you know, uh, the kind of AI platforms that you are seeing here is machine learning is on the rise. Deep learning is again on the rise, and artificial neural networks is something that's being implemented, right? And you could see that computer vision, which is image processing, is rising too. And all of these are really doing a great job in terms of assuring you that you have several different careers in the AI domain itself. On the contrary, when it comes to languages, see how Python as a language has been very steadily rising, right? And learning Python alone can be a very good start for you to enter into the AI platform itself. Okay, so some of the tools that I suggest when it comes to starting your AI platform is first learn Python, right? When you start learning Python, along with Python, there are various ecosystems of Python that you will have to learn, like Pandas, NumPy, Matplotlib, scikit-learn. All of that would come in together, right? So, but Python is critical. Why? Because Python can help you understand the technology side of AI. It has so many different libraries, so that it allows you for better analysis and better predictive analytics capabilities as well. So I would say some of the best tools for learning AI would be Python. Some of the best tools for learning big data would be platforms like Hadoop, and also NoSQL platforms like MongoDB. Right? Those are some very useful tools for you to start with. Okay, so I've given some. When you look at the data side of the story, you have SQL, you have Graph SQL, Graph databases, and then you have NoSQL. There is a steady need for all of this, right? And if you also see, some data transformation and streaming tools are also, like Apache Kafka, are also probably playing a very important role, right? So with this, I just want to end this session with what sums up a data scientist, right? So a data scientist should have a good problem solving mindset. He or she needs to be a little hands on by using tools like Python, and Pandas and NumPy. They should have decent amount of domain expertise. If they don't have domain expertise, at least focus on one domain and start learning it with the help of these tools, right? They should have certain amount of programming skills, right? You cannot be a data scientist without understanding programming at all. You need to have an understanding. You don't need to be a hardcore programmer. And last but not the least, focus on statistics, right? And that's going to be the very important aspect as well, right? I know that we are already on the top of the hour. I really thank you for listening to this webinar, and have a good day, and have a great weekend too. Thank you very much.